atomistic simulation of cementitious systems. I mean, everything is constituted of atoms, and one way of getting a very close look at what is actually happening is to try to simulate really what each atom does within a certain time frame and what are the forces between them. It's a bit of a back and forth. You don't understand something experimentally, or you cannot get the level of detail you would need. Then you can use atomistic simulation, and if that is consistent with the experiment, then you know you're on the right way. If you saw something in your simulations, you had a huge pool of experts who could tell you how this relates to what is observed experimentally, where there is some evidence I could look at which goes into the same direction or would contradict it. And this is a bit unique that you have twice a year you see almost everyone that is doing research in cement and can discuss with the expert you would like to ask a question from, because lots of the information is not necessarily available. And often it's a bit of a problem that fundamental researchers don't necessarily know what is going on in a really applied level, and then the other way around, that what is done on an applied level, they don't necessarily know the newest development on the fundamental level. So this is one gap that is kind of closed by Nanocem. Lots of people think that cement is a very simple, well-known material, but it's anything but. Cement is actually very, very complex. And consequently, there are lots of things we don't really understand. I mean, one of the main constituents of cementitious materials is essentially, it's a nanoscale material, which has very interesting properties, but we don't really understand it yet. Basically, better understanding means better control. So if you understand what is happening, you have the possibility to fine-tune the properties of the material to really the application you want to, or to understand degradation materials better, to prevent them, things like that. Concrete is all around us, so if we can improve the material, it will have a huge impact on daily life.